back together. All right, so we are still continuing on this question paper for the May-June Technical Maths 2024. So please, if you haven't subscribed, just make sure you're part of the family. Right, so let's quickly have a look at the question. They say the movement of a ball thrown from a ball throwing machine forms a parabolic path given by the equation h of t, which is minus t squared plus 6t plus 1.62, where h is the height in meters and the ball above the ground, and t is the time in seconds. Right, now they say to us, determine the initial height of the ball above the ground. Now remember, the initial height would be where our time was 0, right? So all we need to do is take h of 0. So in that case, I'm sure you can see that that will give you 1.62. Right, so that means that the initial height was 1.62 meters. All right, now they say determine h of t. So that's h, or rather h prime of t. Okay, so that's going to be jumped down. That's minus 2t plus 6. So that's how we're going to get h prime of t. That's minus 2t plus 6. And they say, hence, calculate the maximum height the ball reaches. Now, what happens at maximum height? In this case, the velocity becomes 0. It means that this is where h prime, right, would be equal to 0, right? So we're going to say this is h prime of t, which is negative 2t plus 6, all right? And this would be equal to 0. So when would that happen? So negative 2t is equal to negative 6. And if I divide both sides by negative 2, I get t is equal to 3 seconds, right? So in this case, I'm not interested in the time. I want the height. So what would be the height at 3 seconds? So please remember to substitute back into the original equation, not the derivative. Okay, so that's 3 squared plus 6t, right? 6 times 3, that's plus 1.62. Okay, so we're going to get minus 9 plus 18 plus 1.62. And I am going to get 10.62 meters, and that's the height. Okay, right, so please keep that in mind. That's where I will get my maximum height. All right, now the final question, they say to us, determine the height of the ball above the ground when it reaches a velocity rate of change of 3 meters per second. Now remember that the rate of change is actually calculated or determined by the derivative. So when you've got a height, you get the derivative that represents the rate of change of displacement or of the height in this case. So we want to find out, okay, h prime of t, we said that's minus 2t plus 6, okay, and when is that equal to 3? So I'm going to say that's minus 2t is equal to, when I take this to the other side, that gives me 3 minus 6, that gives me minus 3. And to divide both sides by negative 2 gives us a time of 1.5. And remember that the time was measured in seconds, right? So that's 1.5 seconds. But they said to us, determine the height, okay, of the ball above the ground. Okay, so we are going to simply say, again, back into the original equation, that's h of 1.5 I'm going to say that's 1.5 negative rather 1.5 squared plus 6 times 1.5, and that's plus 1.62. So please, if you can calculate that for us, that's negative 1.5 squared plus 6 times 1.5 plus 1.62. And I get a value of 8.37 meters. Right. Ladies and gentlemen, that brings us to the end of this question. Really interesting. A good application of calculus. Okay, so I will see you guys again when we look at the next question. We're about to finish with this question paper. Let's do that. I'll see you guys next time. Sharp, sharp.